page. K minus 42 equals 75. So we need to take a number bigger than these two and subtract 42 from it to get 75. So K is going to be 75 plus 42. 5 plus 2 is 7. 7 plus 4 is 11. Now, I'll put K equals 117. So if this is correct, 117 minus 42 should give me the 75. 2 from 7 is 5, and 4 from 11 is 7. So 117 checks. Number 11, when you add fractions, you have to have common denominators. So, and that denominator will stay the same. So 2 plus 1 as the numerator will be 3/5, and that is in lowest terms. Number 12, again, when you subtract fractions, as in addition, you have to have common denominators, which we do. And we have 7 minus 3, which is 4. This one is also in lowest terms. Number 13, multiply fractions. To multiply fractions, you need to multiply numerators times numerators and denominators times denominators. So 2 times 4 is 8, and 3 times 5 is 15, which is in lowest terms. If you remember back in lesson 1, we talked about parentheses as another way of writing multiplication. So this simply means 21 times 12. So let's go over to the side and do 21 times 12. Community property says it doesn't matter which number you put on top. 2 times 1 is 2, 2 times 2 is 4, 1 times 1 is 1, and 1 times 2 is 2. We add, we get 2, 5, 2. So we get 252. Okay. Draw and shade circles to show that 1 1/2 is the same as 3/2. So let's draw 2 circles. So we've got 1 and 1. So we need to divide them up in halves. And so one circle will be the 2 sections here, and then the 1/2 section will be here. Now that's enough to answer the question, but I like to actually write like I did in the notes. I like to write that this one is 1, and this is 1/2, which is 1 1/2. But this is also 1/2 plus 1/2, which is 2/2, plus 1/2, which is 3/2. You don't have to do that to get that problem, but I like to do that because it kind of shows that those are the same thing. Name 3 segments in this figure in order of length from shortest to longest. Well, we're talking about segments, so we need to use segment notation. I think you would agree that AB is the shortest one, so we'll put a little bar above that. And then BC is going to be the next one. And then the biggest one is the combination, which is AC. Number 17. When you have a problem with parentheses, you want to do that part first. So hopefully we know that 3 goes into 12 4 times. So now this problem becomes 144 divided by 4. So let's go over here and do that. 4 into 144. 4 goes into 14 3 times, and 4 goes into 24 6 times, evenly. So all of this is equal to 36. Okay, write the set of whole numbers. Well, there's a key word here, set, so you want to put them in set brackets. And the whole numbers are what we count with, the counting numbers, but they also include 0. So we've got 0, 1, 2, 3. You can write them as far as you want to, but be sure and continue that with the 3 dots to show that it goes on forever. Number 19, 15 over y is equal to 3. So we need to know a number that divides into 15 3 times. So if we want to know that number, we can go back and do 3 into 15 to get 5. So we get y equals 5. Now again, let's check that. I think it'll make it easier for you, especially on tests. So you've got 15 over 5, which is 3. And we do agree that because 15 over 5, 15 divided by 5 is 3. So that one checks real easily. And number 20 says draw a pair of perpendicular, now notice it says lines. Lines go on forever. Well, perpendicular means they intersect in a right angle. Now, I'm not going to use a ruler. You don't have to use a ruler to do it. So I'm just going to kind of eyeball it and draw me a line. And then I'm going to draw another line through it at any point. It didn't say specifically where. And to show that they're perpendicular, I'm going to put that little right angle there, a little square, to show that there is a right angle in that corner.